spelling errors. By using the existing edit distance algorithm as the basis of your code to detect spelling errors rather than coming up with your own, you'll benefit from reduced development time, reduced testing, and easier debugging of your code. That's why it's very rare to find code that doesn't use existing algorithms in some way. The iOS SDK is a good example of existing algorithms. They make the process of building an app much easier than if you had to write all of the code yourself. For example, to draw all of the letters of all of the text on screen. Now it's time to correct the remaining errors in your survey data. You'll solve the problem with a modular solution. Exercise. First, complete the function below, which returns the closest matched in the show catalog for a given string. The edit distance function is implemented elsewhere so that you can use it without its code cluttering up your solution. So this looks through the potential matches array to find the item that most closely matches the string in the first argument and returns that string. So function closely match, and then for a string from potential matches, an array of strings, returns a string. Initialize the best edit distance to the worst possible value. So variable best edit distance gets int.max. So that's the highest one. Initialize the index of the best match to the first index. So variable best match index gets 0. So that is initialized to the first index, which is always 0. So for each index in 0 to potential matches dot count, get the potential match at index I. So let potential match get potential match is at the index I. Get the edit distance from the string to the potential match. So let distance edit distance from string to potential match. So that's going to check that distance. If the distance calculated above is better than the best edit distance, update the best edit distance and best match index. So if distance is less than best edit distance, the one that is currently being stored, because we're trying to find the best of the best, then best match index gets our current, and best edit distance gets distance. And then return potential matches. All right, exercise. Starting with your solution code from correcting errors, add the following steps. After you've created the lowercase version of the survey value, check to see if it is in the lowercase version of the show catalog included in this playground page as lowercase catalog. If it is, tally as usual. If it's not, tally the closest match from the catalog. As a bonus, print the errors and their corrections when you find them. Be careful, if you copy and paste your solution code, be careful not to lose the new comments on line 73 and 74 below. So, the lowercase version of a show catalog has already been created. So lowercase catalog, this is our show catalog. We will just trust that that is there. So then we are going to print this third cleaning pass and then tabulation for valid data. Those are just some headers. Create a tabulator instance. So var tabulator. There is a tabulator instance, and then loop through survey data, make a lowercase version of each value. So for each show in survey data, if the catalog contains the value, increment its count. So if, oh, we forgot, let lower show get show dot lowercase. So we are making lower show the lowercase version of the show. So if lowercase catalog dot contains lower show, then increment count. Oop, nope. Clearly there's an error, but I'm going to type this and then look for it. Lower show. Ah, forgot my curly bracket. There we go. So if lowercase catalog contains lower show, tabulator increment count for value lower show. So this is just counting those shows if they were just a case, so uppercase or lowercase errors. So otherwise, find the closest match for the value and increment the count for that. So else, we are going to let show closest match get closest match for the lower show, so the lowercase version of that, from lowercase catalog. There we go. So we're looking for the closest match in lowercase catalog of the lowercase show. And then tabulator. So we're going to add that increment count for value show closest match. So the closest match that we found. And we're going to add that to that show's increment. Then we're going to print the show tabulator count for value show closest match. Then we need to close some brackets. Just that one. Oop. Didn't autofill. That should fix that. Yeah. All right, now we are going to loop through all tabulator values. Print only those that are contained in lowercase versions of the show catalog. So for each show in tabulator values, if lowercase catalog contains show print show, we're pretty used to this one by now, and then tabulator count for value show. All right, and then we have a bracket to close. And then we're printing a header, create a variable to keep account of the errors. So variable error count. We're going to initialize that to 0. Loop through all tabulator values. So for each show in tabulator values, dot values. If a value is not contained in the lowercase show catalog, so if not lowercase catalog dot contain, so if it doesn't contain this show, then increase the error count plus equals 1, and then print it. So print show. And then we are going to close some brackets and then print the error count and see how many errors we have now. Hopefully none. Print. Total errors. Error count. And run. Total errors, 0. Most excellent. So we have third cleaning pass, tabulation for valid data. All of these are in the list. Notice they're all more than one. Then data errors, no errors. So there are 0, and none of them are listed here. Wonderful. Thanks for sticking with me through that one. Next, we have higher order information.